Get this. AI might be on the verge of understanding language in a whole new way. Not through words, but through bytes. Pretty crazy, right?
Yeah, it really is. It's like we're breaking down language to its most basic elements. Kind of like how understanding atoms helps us understand the universe, you know?
Okay, I'm following. But how does understanding bytes actually make AI smarter?
Well, it all comes down to how AI currently processes language. Right now, it relies on these things called tokens, which are essentially predefined chunks of words or phrases.
Like AI is reading a book that's already been cut up into pieces.
Exactly. It misses out on a lot of the nuance and context.
That makes sense. So where does BLT come in? What's so special about it?
BLT, which stands for Byte Latent Transformer, ditches those predefined tokens entirely. Instead, it goes straight to the bytes, the raw data of language.
BLT, huh? Sounds more like a sandwich than a revolutionary AI breakthrough.
Uh-huh, right. But it's pretty ingenious how it works. Imagine reading a sentence. You speed up on the familiar parts, but slow down when you hit a complex word or phrase.
I do that all the time.
Mm-hmm.
So BLT is like a speed reader for AI.
Exactly. It groups bytes together into these dynamic patches based on how predictable the next byte is. If it's easy to guess, the patch gets longer. If it's a surprise, it starts a new patch.
Interesting. So it's constantly adjusting its focus based on the complexity of the text. But does that actually improve its understanding?
That's the cool part. Researchers did a head-to-head comparison, training BLT alongside those traditional token-based models like Llamo.
And how to do?
BLT matched or even exceeded the performance of those token-based models on various tasks.
No way. So it's not only a new approach, but it's actually better. What's the catch?
There are always challenges, but get this. DLT achieved those results using up to 50% fewer computational steps.
Hold on. It's smarter and more efficient. Sign me up.
Right. It's a big deal, especially for companies using large language models. They could cut costs significantly.
That's huge. Less processing power, faster results, lower costs. I get why this is exciting for the industry, but what about for me? How would BLT actually change my experience with AI?
Well, think about all the times your voice assistant mishears you because of background noise or a slight mispronunciation.
Oh, tell me about it.
Yeah.
My smart speaker thinks I'm asking for the weather in Westeros half the time.
Exactly. Those everyday frustrations could be a thing of the past. BLT is way more robust to that kind of messy input.
So it's more forgiving. It can understand us even when we're not perfectly clear.
It's like BLT is learning to read between the lines, or rather between the bytes. And there's more. BLT has shown some amazing abilities when it comes to tasks that require understanding language at a really granular character level.
Okay, I'm intrigued. Like what? Give me an example.
Well, it aced a test where it had to manipulate text based on specific character instructions. Imagine telling it to swap every A with a B in a sentence. It could do that flawlessly.
Wow, that's impressive. It's like BLT isn't just understanding words, it's understanding the very letters that make up those words.
Exactly. And that opens up a whole new world of possibilities, especially for things like machine translation.
Okay, now we're talking. Breaking down language barriers, that's a big deal.
Especially when it comes to translating languages with limited data available. BLT consistently outperformed token-based models in those scenarios.
That's incredible. Making information accessible to everyone, regardless of language. It's like BLT isn't just about making AI smarter. It's about using AI to make the world a more connected place.
Yeah, I totally agree. And it all comes back to that fundamental shift, moving away from tokens and embracing the power of bytes.
This is all fascinating, but it can't all be sunshine and roses, right?
Yeah.
There have to be some limitations. Is BLT perfect?
Of course not. It's still early days, and the research is just getting started. We need to see how these models scale as they get larger and are trained on even more diverse data.
So plenty of room for growth and improvement, but that also means there's so much more potential to unlock.
Exactly, and that's where things get really interesting. One avenue the researchers are exploring is byteifying existing large language models.
Byteifying. Now that sounds like something straight out of science fiction.
It's not as complicated as it sounds. It's essentially transferring the knowledge from a traditional token-based model to a byte-level model like BLT.
So instead of starting from scratch, we're giving BLT a head start, like building on the shoulders of giants.
Exactly, and the early results are promising. We might not need to reinvent the wheel every time we want to enhance AI's language abilities.
That's exciting. Less work, more progress. But what does all of this mean in the grand scheme of things?
It's hard to say for sure, but this research on BLT could be a major turning point. We might be on the cusp of a huge shift in how AI interacts with language.
A world where AI understands us better, adapts to our quirks, and maybe even learns new languages as easily as we do.
It's definitely a possibility. And that raises a pretty thought-provoking question. What kind of future do you envision with AI that seamlessly adapts to the way we communicate?
That's a good one. Lots to ponder there. But before we get too lost in futuristic scenarios, I think it would be helpful to dive a little deeper into how BLT actually works.
Yeah, let's break it down.
Okay, so in part 2, we'll unpack those nitty-gritty details of byte-level processing and explore those dynamic patches you mentioned earlier.
Sounds good to me. Okay, so let's unpack BLT and see how it actually works. Remember, we talked about those 3 key modules, the local encoder, the global transformer, and the local decoder. They all work together to process and understand text on a byte level.
Right, the byte-level dream team. Let's start with that local encoder. What's its role?
It's kind of like the first step in the process. It takes that raw stream of bytes, the ones and zeros that make up digital text, and turns them into something the global transformer can understand. You know those dynamic patches we talked about? That's what the local encoder creates.
So it's translating byte language into patch language.
Exactly. It's like a translator, but a really smart one. Instead of just cutting the text into fixed-sized chunks, it looks at those bytes and groups them based on how complex they are.
Hold on, how do you measure complexity at the byte level?
It's all about predictability. The encoder looks at how easily you could guess the next byte based on the ones that came before. If it's a no-brainer, the current patch keeps going. But if it's a surprise, bam, new patch. That's a signal to the global transformer, hey, pay attention here.
So the patches are like little containers of information, and the tricky stuff gets its own container. Gotcha.
Yeah, and to give the global transformer even more context, the encoder adds information about the preceding bytes to each patch. It uses these things called hash n-gram embeddings.
Hash n-gram embeddings. Now you're just showing off.
Haha, it sounds fancy, I know. Think of them like tags on each byte that say, hey, this is how I relate to the bytes that came before. They help the global transformer get the flow of the text, even with these compressed patches.
Okay, so the encoder is all about keeping things efficient while still holding on to the important stuff. Makes sense. What happens next? The global transformer.
Right. The global latent transformer is like the brain of the operation. It's a big neural network that's learned from tons of data. It takes those patches from the encoder and uses all that knowledge to predict what comes next in the sequence.
And because the patches already have so much packed into them, the transformer can work faster, right?
Exactly. It doesn't need to waste time on every single byte. It gets to focus on the big picture, understanding the meaning and how the patches relate to each other.
Okay, so that's where the efficiency comes in. But we're not done yet, right?
Yeah.
We need to get back to those original bytes. That's where the decoder comes in.
You got it. The local decoder takes what the transformer gives it and turns it back into bytes, rebuilding the original text.
So it unpacks those information containers and puts the message back together.
Precisely. It has a clever way of mapping those patches back to the byte level. And just like the encoder, it remembers the preceding bytes to make sure the output is smooth and makes sense.
This whole system is pretty impressive. It's like a dance between these 3 parts, each doing its job.
It's all about finding that balance between compressing information and still understanding it. BLT compresses just enough to make things efficient, but it doesn't lose the meaning.
I see. But how do they figure out that sweet spot for compression? How does it know when to create a new patch?
That's where the patching scheme comes in. It's basically the set of rules for how the bytes get grouped.
And with BLT, they're using a dynamic patching scheme, right? One that changes depending on the complexity of the text.
Right. They tested a few different ways to do it. One idea was to start a new patch every time there was a space, so words would be the basic unit.
Yeah, that seems logical since we naturally break language down into words.
But they actually found an even better way. They used a separate, smaller language model to estimate the entropy of the next byte.
Okay, hang on. What's entropy in this context?
Think of it as a way to measure how surprising the next byte is. High entropy means it's hard to predict. When the entropy goes above a certain point, boom, new patch.
So BLT is always trying to guess what's coming next and adjusting on the fly. That's pretty slick.
And this dynamic patching turned out to be super effective. It's one of the main reasons BLT performs so well and is so efficient.
I'm starting to get the picture. So we've got these 3 main parts in this dynamic patching scheme.
Mm-hmm.
What else is important about how BLT is put together?
One crucial thing is cross-attention. It's basically how the local encoder and decoder can communicate with the global transformer really effectively.
How does that work? I'm a visual learner.
Imagine it like this. The encoder uses cross-attention to gather information from those individual bytes and packs it into the patches. Then, the decoder uses cross-attention to unpack those patches and put everything back together at byte level.
So it's like a two-way street, making sure the information flows smoothly between all these different levels.
Exactly. It's all about communication. And the researchers found that this cross-attention was crucial for BLT to do its thing.
It really is amazing how all these different parts work together.
It really is a testament to how clever the researchers are, and the results speak for themselves. BLT not only keeps up with those traditional language models, but also beats them in some ways, like being more robust and efficient.
It seems like BLT could be a game changer for AI.
Absolutely. And remember, this is just the beginning. As these models get better and are trained on even more data, who knows what's possible with byte-level language understanding?
It's exciting to think about what the future holds. AI that can handle our slang, typos, even our accents. The possibilities are mind-blowing.
It's definitely a future full of potential, and I'm excited to see where it all leads.
But before we get too carried away with all the possibilities, let's bring it back to the present. How is BLT already impacting the real world? Ready for part 3. All right, so we've talked a lot about the nuts and bolts of BLT, but I'm really curious about the real-world impact. What can this thing actually do?
Well, remember those ant speak memes where every letter is capitalized and spaced out? BLT actually handled that messed up text way better than those traditional models.
So it can understand us even when we're being intentionally weird? That's kind of reassuring.
Exactly. It shows that BLT is way more resilient to noise and variations in language. It doesn't get thrown off by bad grammar or spelling as easily.
It's like it's learning to read between the bytes, filling in those gaps when things aren't perfectly clear. But what about real practical uses?
One area where it really excels is in tasks that need understanding language at the character level. For instance, it's great at figuring out how to pronounce words just from their spelling.
So if you give it a word, it can say it out loud? That's pretty cool.
Yeah, and it even did really well on a test where it had to manipulate text based on specific character instructions, like swapping certain letters within words.
Wow, most AIs would totally struggle with that. It really shows how BLT has a much deeper grasp of the building blocks of language.
And this mastery of character-level details is really helpful for machine translation, especially for low-resource languages.
Low resource, what does that mean?
It means languages that don't have as much training data available. Maybe they're spoken by smaller populations or haven't been digitized as much.
I see. So BLT could help make information and technology more accessible to people who speak those less common languages.
Exactly. It consistently did better than token-based models when it came to translating between English and those less resource languages. Breaking down those language barriers is a big deal.
That's amazing. It's
Yeah.
like BLT is helping to level the playing field when it comes to language access. It's not just making AI smarter, it's about using AI to make a positive impact on the world.
I completely agree. And that ties back into the idea of byteifying those existing language models. Remember, we talked about that.
Giving those older AIs a bite-sized upgrade.
Basically, yeah. It's a way to transfer the knowledge and abilities from a traditional model to a byte-level model like BLT.
So we don't have to start from scratch with BLT. We can build on what those other AIs have already learned.
Right. And the early research suggests that this process is really effective. We might not need to reinvent the wheel every time we want to make AI better at language.
That's pretty exciting. Less work, more progress. But stepping back for a second, what does all of this mean for the future? Where do we go from here?
I think this research on BLT really highlights how much potential there is in finding new approaches to AI and how it processes language. We're still in the early stages, and there's so much more to discover.
It's like we're at the edge of a huge unexplored territory, and BLT is our first step.
Exactly. As we learn more about language and build even more advanced models, the possibilities are endless. Imagine AI that can translate between any language, understand complex code, or even write creative text like a human.
A future full of challenges for sure, but also incredible opportunities. It's going to be fascinating to watch it all unfold.
And hopefully this deep dive gave you a glimpse of what that future might hold. Thanks for joining us.
Absolutely. Until next time.